The title of the presentation is 5 Rules for Super Responsive Serverless Apps. So please welcome on stage our first presenter of today with a huge virtual applause, Gojko Adzic.
So thank you, everybody, for joining this session. My plan today is to talk a bit about some interesting discoveries and interesting conclusions we found while building applications deployed on AWS Lambda. That's kind of the first popular serverless platform. Some of the conclusions that we had will also apply to other providers, and I'll talk about that a bit, but most of the talk today will apply for people that are deploying to AWS. I've been working with AWS Lambda since 2016, and we have a relatively popular product used by millions of school children all over the world that's working fully serverless. I've also created another product now aimed at developers to create videos easily. And it's also deployed on AWS Lambda. And that's given me some interesting experiences that I want to share with you. Mostly serverless platforms and function-oriented platforms are emerging on all cloud providers today. And they seem to be optimized for throughput, not for latency. And there's a big kind of scare, and lots of people on blogs and on the internet are commenting how that's not really good to run responsive websites. And I think that's wrong. And I want to give you a couple of kind of interesting points how you can actually squeeze out very, very good performance out of applications deployed in a serverless way, and how you can get as much out of that as you would from kind of regular web servers and things like that. So one of the first interesting things to note is that this way of deploying and running applications is evolving very rapidly. So documentation that's been online for a few years kind of is sometimes outdated, and you can get misled by best practices for things like that. So case in point, for example, is there's 2 ways of running API endpoints on Amazon. And if you look at the documentation, they kind of explain how one is better than the other. So one is called a regional API endpoint, where in fact, when you deploy an API, say in Central Europe or in Western United States, the clients will connect from wherever they are using HTTP directly there. Then there's another type of endpoint that's called an edge optimized endpoint. And Amazon explains this as kind of, if you are, say, in Europe, and the API is deployed in Western US, instead of the browser request going directly to the Western US, the browser request here goes into the closest Amazon endpoint. That would probably be in Frankfurt if you're in Central Europe, or Paris or London if you're in Western Europe. And then it will use Amazon's infrastructure to go where it needs to go to Western US. And they say this typically improves connection time or reduces latency for clients all over the world. And if you look at kind of their offering, they have 225 points of presence and points all over the world. And based on the documentation, it looks like this is a really, really good thing to do. So the difference in terms of configuring those 2 things is not really that problematic or complex. All you need to do is, if you are deploying using CloudFormation, you can say endpoint configuration is regional or endpoint configuration is edge. And this is an interesting thing to consider because Amazon has really, really good infrastructure and cloud providers have good infrastructure. And you would expect that kind of routing from one Amazon region to another is a lot faster than routing from kind of somewhere around the world directly to an Amazon region. So this is one of the things where I mentioned you shouldn't really trust documentation as itself. So different endpoints or different locations really have different response times. So I've run a couple of tests. For example, I was running a test for a client who's in Stockholm, and we were trying to see, well, if most of your clients will be in Stockholm and you have to deploy to a specific region for some reason, let's say US East 2, What's a better option to use? Is it better to use an edge or a regional endpoint, especially now that Amazon actually has a point of presence in Stockholm? So you would expect that kind of people in Stockholm would be able to connect faster through a edge point. Now, running these tests, as I said, I found some interesting results. So in average, if I look at the data here, the regional endpoint was performing, well, 5 to 10% better than the edge endpoint, which doesn't make a lot of sense according to the documentation. And this was consistent. It doesn't matter how many times I've run this stuff. So it turns out that if you're in Europe, for example, or if you're in the US, or if most of your clients will be in Europe or the US, and you really want to shave milliseconds, deploying counter to the documentation, deploying that as a regional endpoint, not as an edge endpoint, makes a lot more sense. If your clients are in Australia, or you expect most of your clients to be somewhere where there's really bad internet, maybe deploying an edge endpoint makes more sense. But the point I'm trying to make is the first rule of really squeezing out performance out of serverless applications is don't really trust documentation. Don't trust anything you read online, especially if it's ordered in a few months. Go and test that stuff. Test it for yourself. And if you want to kind of run tests like this very easily, I've open sourced a tool called Inquisitor. With Inquisitor, you can deploy a regional edge API, and you can deploy lots of different combinations of authentication, and they just from the browser very quickly get tests. So you can go to github.com serverless pub Inquisitor and just download this. You can install it with a single CloudFormation template into your account, and then run lots of tests with lots of different combinations, and actually see whether you're optimizing this correctly or not. Don't trust documentation. Another thing that's really interesting that started happening over the last 2 years maybe is how the whole infrastructure started to change in terms of what they're offering. Initially, when serverless platforms got started, or kind of when AWS Lambda got launched, Tim Wagner, who was the head of the Lambda at AWS, defined a serverless way of running as deliver compute on demand. Whenever you need it, as much as you need it, it's going to scale automatically. And you never, never, never need to pay for idle. The big difference between running things on Lambda and running things through containers or on EC2 or Heroku and things like that is, if people are not using your system, you don't have to pay for it. If lots of people come, you pay. But then if the scale goes down, you don't have to pay, and you don't have to manage capacity yourself. This is something that Amazon will do for you, or Microsoft or Google. And the big problem with that is that you are trusting Amazon or Google or Microsoft to decide how many instances of your application to launch and when. And back in 2016, one of the big problems people were facing, if they really want to squeeze latency, not throughput, is these kind of starting up a new instance and cost of starting a new instance. That was called the cold start. Now, if you Google for kind of Lambda and things like that, lots of stuff all comes on Google and lots of advice on blogs about really kind of problems with optimizing cold starts and improving Lambda performance, especially if you try to reduce latency. And, Google comes out number 2, well, keep Lambdas warm. Keep Lambdas warm basically means somehow through black magic or through poking your system, or Amazon now added this as a proper solution, keep a few instances going all the time, which used to be good advice, but I'm not so sure about that anymore. And somewhere in 2019, Microsoft started offering an enterprise version of this. If you were on a Microsoft Premium plan, you could have warm instances for Azure Cloud Functions, and you could reserve instances and they would keep them warm to reduce latency and serve users. And as soon as they launched this and somebody started paying for it, at Amazon, basically Bezos said, well, somebody's paying Microsoft for this. I want to be able to take people's money for this thing as well. And then in December 2019, Amazon also launched their own version of this. So you can actually say, well, I want to have 20 provisioned instances or 5 or 500, and these things will be ready to receive customer requests, so we minimize latency. Now, it would sound logical that this thing optimizes your performance, but again, if you test it, and especially if you test it today, these are some test results I got recently. I was executing tests using Inquisitor, and I set it up to run 12 provisioned instances, and bombarding it with parallel requests with 12 provisioned instances or with no provisioning. Actually, the performance was marginally better with kind of no provisioning. In some cases, that's kind of in the margin of error. And what's also interesting in this case is even if I told it, go and give me 12, as I was bombarding this stuff, it actually gave me 26 instances at some point. So again, you can get this kind of data using Inquisitor. And the big question is then, how do you know how much to provision? Because Amazon in one case does all the capacity planning. In the other case, you tell it, give me 12, but if there's more demand, take more. And it's a big question, how many more do we need? So in a meta level, you can actually create an auto-scaling system where you just, this is an example, you create an auto-scaling target where you say between 1 and 100 capacity, and my scaling policy is such that I want this target value, 0.70, to be served by provisioned instances. Now, this can get really, really complicated. There's lots of people writing about this, and it's sounds like if you really want to squeeze latency, you need to think about this very carefully and manage this in a complicated way. But for me, provisioned instances are a perfect example of an Amber AWS feature. And Amber features are there for one purpose only. They actually make Bezos even richer. So the whole purpose of this is to take money from large enterprises that basically don't trust good algorithms. For us, we've been running with automatically provisioned, automatically scaling Lambda instances on both of these platforms, and we have really good metrics for end user client experience, and we've not really found a good use case for keeping provisioned instances. Now, there's a caveat to this, and if you look at what's been happening over the last couple of years, especially on Amazon, the initial starting time has reduced significantly. So 5 years ago, initial starting time for a new instance was up to a few seconds, but now you can use data. There's a wonderful blog by a guy called Mikhail Shilkov, and he publishes this data every few months. He does his own tests. He's an independent. And if you look at his current data, basically starting up a new instance that's serving Python or Go or JavaScript is, within 10, 20 milliseconds, your users are not going to notice when something like this starts. Plus, if you have a lot of traffic, Amazon will reuse these instances. So if you have your own Docker containers and they're getting very complicated, then maybe keeping provisioned instances is still important, but even that is less than 1 second. So rule number 2, if you really want to squeeze latency out of your serverless applications, is optimize on the time to start. Optimize kind of the time for your application to start receiving user requests once the instance is running, because the instances start very quickly now, and most of the time the bottleneck is actually on the application developers. And if you do that, the rest becomes very simple. Then you don't have to worry about provisioned instances. You don't have to worry about any of this complicated stuff. You can just use Amazon's algorithm for this, or Google's algorithms and things like that. Now, this is the part where things differ between different cloud providers, and you really do need to test your own stuff or find somebody who tests their stuff. So again, if you go to Mikhail's blog, he publishes data for lots of different cloud providers. The data he had for Azure in January is still a bit depressive. So unlike Amazon, where, for example, with JavaScript or with Python, things start really, really quickly. With Azure, you can still have up to a few seconds of start time, even up to 20 seconds of start time if your functions are written in PowerShell. And then keeping stuff warm might be really, really important. Now, optimizing for start time sometimes has unexpected avenues you need to explore. And this is where you need to start looking at how you're designing your functions and what's happening there. So if your functions are, say, in Java, there's two things that happen in those functions. One happens once per call start, and this is the static context. So that's kind of this part above. And the second happens on every request. This is kind of inside the execute method. And the way we've been used to designing three-tier applications is, well, load up your database connections, cache everything you need to cache so that each request is quick. But in case of designing for serverless, actually, we need to start thinking slightly different. The stuff that happens once per call start really needs to be thin. The start that happens on every request, that can, use optimistic caching and things like that. So optimize the cold start part. If you're doing something kind of Pythonic or JavaScript, then the stuff that's outside your handler function, the global context happens once per start, and the kind of body of your functions happens on every request. So don't go crazy and pre-cache and optimize everything. Use optimistic caching. Get the function to start quickly, and then you can kind of figure out what you need to cache and what not. And again, sometimes this kind of stuff can become a bit weird. Here's a graph of performance optimizations that kind of I've done a year or so ago, where we've been trying to troubleshoot why one of our functions is slowly responding. And you can see kind of, this is the medium response time for this function from start to finish. And once we've kind of figured out what was going wrong, you can see how much it dropped. And the curious thing was we did not change our code at all. What happens as kind of these things become so isolated and so quick and start running quickly is the time to establish a connection to the database was actually longer than the time for a function to process its own work. And on every request, we were establishing a new connection to the database because that's how the client SDK was defined. Now, we discovered that this magic environment variable called connection reuse enabled for the JavaScript SDK, where basically it will keep alive a network connection to Dynamo or to S3. Once an instance establishes it, it will reuse it. And that was basically the cause of this drop. So once we established a connection from one instance, subsequent requests would reuse that HTTPS connection. So when you get to the point where the HTTPS keep alive is really killing you, that's kind of where you're starting to optimize for latency. So if you use your own kind of parameters for instantiating clients, the equivalent would be something like this, where when you create an HTTPS agent, give it keep alive true. That's basically the trick that once you shave off everything you can, start looking at the SDK. With the new SDK version 3, this is on by default. Why this wasn't on by default with kind of V2, I don't know. And hopefully as V3 matures and becomes more usable for everything, people wouldn't have to worry about this. So rule number 3 for effective serverless applications and for really getting the latency out is cache the context. Lots of people approach serverless deployments on all cloud providers as something that's totally stateless. And these instances are not stateless. You're not guaranteed to run on a certain number of instances, and the provider can start them or shut them down. But when you have a lot of traffic, and that's where you especially want to reduce latency, the cloud provider can decide to reuse a single instance for multiple requests. So really, skip caching on start, but use the context to cache between the requests so you can optimize for subsequent requests. Now, another thing that's interesting, and this is where going back to edge or regional and things like that comes in, is what we can now do with these systems. Usually, 2 instances or 5 instances of your application would cost 5 times more or 2 times more to run. And this is still true if you use provisioned instances. If you let the system scale on its own, most of these cloud providers will charge you per request. So what's interesting about that is if you have 50,000 users using your system at the moment, and they're using only one version of your application, that costs absolutely the same as if they are using 20 different versions of your application. And this opens up an interesting opportunity cost-wise. So in a sense, if your users are in Europe and your system is in the US, there's very little you can do to shave kind of a latency caused by the basic laws of physics. So there was a Cisco measurement article where it's not just the kind of speed of light, it's network switching and things like that. But usually if you think about sending a network packet through a fiber network halfway around the world, that adds about 70 milliseconds. That's the least it can add. And if your function is running in 20, 30 milliseconds and it starts in 5 milliseconds, then kind of the connection between the clients and your function is what's causing the biggest issue. And again, using Inquisitor, you can test all these different things. And the cloud providers, again, introduce a bit more delay than just this 70 because how their software works. So I've done a bunch of tests using Inquisitor. And this is, again, from Stockholm in Northern Europe for a few months ago. So with an application that's deployed in the same geographic region as the clients, so if we're testing from Stockholm and we're going to EU North 1, on average, with the regional API, end-to-end, the client was executing and returning back in 37 milliseconds. The minimum was 22 milliseconds. So that's how quickly the whole thing can work. From the browser to an API, to a cloud function, and back to the browser again. And as soon as this is somewhere a bit further away, same function, same code, same kind of browser infrastructure just deployed in the eastern coast of the US, well, you know, we've added about 100 milliseconds to it. Deploy an application to the western coast of the US, and we've added about 70 milliseconds more. And that's where most of the latency actually comes from, not from your application if you thin it up. So rule number 4, really, for if you want to squeeze as much latency as you can, is deploy your workloads very close to your customers, especially because this doesn't need to cost more. This is a really interesting opportunity, but that also means don't use provisioned instances because that's going to be very, very slow then, and you'll have to pay, so not very slow, you'll have to pay multiple times. If you don't use provisioned instances, you just pay per request, so it doesn't really matter how many deployments you have. There's a couple of things to investigate there. I don't have time now to go into all of this, but you can investigate this yourself. DynamoDB global tables basically replicate everything within a few milliseconds globally. And then you can have a single global table and APIs and functions accessing the table locally. For something where you don't really need millisecond stuff, AWS S3 also has replication. The replication works kind of in a matter of minutes. So kind of they guaranteed 99.99% of the time to replicate content within 15 minutes. And if you're thinking about relatively static assets and things like that, this might be a really good thing to do. And this brings me kind of to the last topic where a lot of people are using S3 or object storages like that to store static assets, and they're using cloud functions, AWS Lambda, Azure Cloud Functions, Google Cloud Functions, as a replacement for the web server. So kind of you replace a typical 3-tier application where there's a web server or application server and then file storage and things like that with an infrastructure like this. And this is like totally super amber. This makes Bezos fantastically rich. Please don't do this. There's lots and lots of ways to reduce latency and speed things up and run cheaper. First of all, on Amazon, you can use the CDN, CloudFront, to directly connect to static assets on S3. So don't use Lambda to serve static files. Don't use it as a web server. don't even use it for semi-static stuff. So you can create or inject a Lambda in between an origin request and origin response, and then just add headers or mutate things a bit. You don't have to load stuff from S3, ship it back. That's how you can reduce latency quite a lot. The other thing, don't use cloud functions to move data between services. What you can do is if you're using an API gateway, you can connect API gateway directly to a lot of these backend services, such as Event Bridge or SNS and things like that. Don't use Lambda as something that copies data from one service to another. Another thing that often introduces latency that I strongly recommend you don't do is don't use Lambda as a gatekeeper. So often people moving from a 3-tier architecture to serverless deployments think about cloud functions as, again, an application server. So you send a request from a client through the API into a cloud function, and that then authorizes access to a database or a file storage. Because all these functions use Amazon's security mechanisms, such as IAM, what you can do is actually just create a security signature and send it back to the client. And then the client can directly connect to storage, for example, and download a large file. And that's how you can also reduce quite a lot of latency. And lastly, please, please, please do not use Lambdas for coordination or orchestration. So a lot of times I've seen people make a mistake by, say, uploading a file from a Lambda and then waiting for something to process and then sending something back. You're just paying unnecessarily for this. So usually all these services have events they can fire. For example, this is how our file conversion for MindMap works. A client gets a security signature, then uploads a file directly to S3. We have an event being triggered when a new file is added to S3. Then the conversion function runs and saves it back to S3. And the client basically just talks directly to storage using the security signature to receive the request. That's how you can speed things up quite a lot. And there's also one really crazy thing you can investigate doing. Amazon has this service called Cognito that allows you to even avoid using Lambdas to generate these signatures. With Cognito, you can use templated security policies. For example, this is a security policy that allows authenticated or anonymous users to access part of a storage only prefixed with their own ID. So this is a security policy that allows a user, say Tom, to go to a bucket /Tom and upload files or remove files. So the last rule to start finishing this off, because I'm running out of time, is really drop delegation. Use Lambda to compute and transform. Use cloud functions or serverless functions to compute and transform, not to secure and transport. Use the platform for that. And having said that, with this Cognito allowing users to access storage directly from the backends, a common way to access cloud functions is to go through the API gateway, but think about, for shaving milliseconds, do you really need an API? Because using Cognito, you can actually authorize a client browser or a client device to directly invoke a Lambda function. And just to finally give you some data on that, if you use the Inquisitor, you can see this thing. Using a regional API in the same region, we've been able to reduce this to 37 milliseconds or 20 milliseconds in average. If you go direct, you can shave a few more milliseconds, and you can get to about 18 milliseconds minimum or 30-ish in total. So that's what all I have for you today. You can find a bit more about this in my book, Running Serverless. And as a small gift for suffering through a remote conference, I know that's not as enjoyable as an in-person conference. If you go to this URL over the next 7 days, you will get the book with a 50% discount. All my slides are already live. You can download them from the URL that you saw. Thank you very much. I can now take some questions.
We have one from Nina. So let's see. In the context of Rule 4, come to customers, could you explain again why provisioning instances is a bad idea?
I don't say necessarily it's a bad idea, but it will duplicate your costs. So if you don't have provisioned instances and you deploy to 10 different regions and you have 50,000 users, that costs the same as when you deploy to a single region because it's priced per request. If you have provisioned instances in each of these regions and you deploy to 10 regions, that increases your operation costs by 10 times.
Thank you. I do not see any more questions yet, but I would be interested. What would consider your biggest innovation in your career? It's more generic, but I would be interested.
What would I consider the biggest innovation? Oh, I don't know. Now you've put me on the spot. That's really difficult.
You are already in the spot.
Question. I think, I started making money before internet really became popular from programming. And I think that everything is networked is, there was lots of innovation since then, but comparing that to everything else, I think that was by far the biggest innovation.
That's great. And do you want to talk about your best conference experience until this point?
No, not really. I think if we don't have any more questions, let's let people take a break.
Okay.
And we'll do that. So thank you very much for attending the talk. I hope you found some interesting tips for how to speed up your applications.
Thank you very much. Thank you very much, Gojko.